In this video, I'm going to go over how to solve absolute value inequalities algebraically. So for example 1, I am going to go ahead and isolate the absolute value. I'm going to take 7 away from both sides. That would leave me with that the left side is now greater than -3. Then a 2 is multiplying the absolute value, so I'm going to divide by 2. And since this is a terminating decimal, a decimal that ends, I'm going to leave it as a decimal. Once you have the absolute value by itself, the most crucial step is to stop and think about if it's a possible scenario or not. And so an absolute value is always going to be positive because it's the distance from 0. So this says the absolute value, which is always positive, is going to be greater than -1.5. Well, yeah, all absolute values, anything that comes out of here is going to be positive, and so it's always going to be greater than a negative. And so when this happens, we write infinite solutions. All right, to check this in Desmos, you just type it in directly. And the shaded area is going to be all of it, is how you know you got it right for infinite solutions. All right, I'm going to skip example 2 and jump to example 3 here. I have example 3. I'm going to take 10 away. I want to isolate that absolute value. I'm now going to divide by the 3. And then I'm going to stop and think about the scenario. And the scenario is, can the absolute value, a positive number, be less than 6? And the answer is yes, it can be less than 6 because there are positive numbers that are less than 6, such as 5. So I split it into 2. I set it up the way that it's written without the absolute value, and then I'm going to do the same thing, but I'm going to flip the symbol and change the sign of the right side. So I changed it to greater than and then -6, and then I just solve away. +4 + 4, x is less than 10, +4 + 4, x is greater than -2. If I were going to plot this on a number line, I would have a -2 and a 10. I would have open circles because they are not or equal to. Less than 10 would go this way, and greater than -2 would go this way if I were drawing arrows. And so the answer is the overlapping of those two numbers. So if the number has to be less than 10 and greater than -2, then it's everything in the middle of those numbers. When you are at this step in the problem where you have gotten the absolute value alone, you should look at the symbol. If it's less than, then it's going to be an and problem, which means it's going to overlap. So maybe take a note that if it's less than, it's always going to look something like this, and we're always going to write our answer as a compound inequality. So this one's going to be x is less than 10 but greater than -2. And so we write that compound inequality the same way every time, where the arrows are always pointing to the left and x is in the middle, because even though this looks backwards, that's still x is greater than -2. We just write it in reverse so that we can write it as a compound inequality. To check this in Desmos, all you have to do is type in the problem. And so I have 3, absolute value of x minus 4 plus 10 is less than 28. And I can see that my shaded areas point into each other, so less than 10 and greater than -2. So it's in between those two values, and those are the two values that I found. All right, number 4, I'm going to add 2 to get the absolute value alone. Everything else gets copied back down. And then I'm going to divide by -3. Just as when you learned how to solve an inequality back in the day without absolute values, you do have to flip the symbol. when you divide by a negative or multiply by a negative. A negative 6 divided by a negative 3 gives me positive 2. This is where I stop and think. Can my absolute value be greater than 2? And the answer is yes. There are positive numbers that are greater than 2. This is what we call an OR problem. So maybe know that if it's greater than, we say greater. So greater, less than is how I remember which way the symbols are, and I'll show you what happens with a greater problem. So I'm going to keep solving. I'm going to split it into 2. You solve it the way that it's written, and then you solve it a second time where you flip the symbol and change the sign. Flip the symbol, change the sign, solve away. Solve away over here, same steps, taking away 1 and dividing by 2. And you could leave these as either decimals or fractions. All right, if I had a number line for this problem, I would have negative 3 over 2. I would have positive 1/2. I would have closed circles because it's or equal to, the numbers are included. Thinking about the arrows of these symbols, I would have greater than and less than, and those symbols point opposite directions. So we just write our answer like this. X is less than or equal to negative 3 over 2, or X is greater than or equal to 1/2. You just write them with an or in the middle to check, and so greater always looks like this. Doesn't matter, closed or open circle depends on if it's or equal to or not. When you type this into Desmos, you will have negative 3, absolute value, to x plus 1, minus 2, less than or equal to, negative 8. You will see that it does go opposite directions. All right, quickly I want to show you some other special scenarios that can happen. In example 6, I went ahead and edited this problem to be what I wanted it to be, so I needed to add a negative sign there. So I'm going to add 9 to both sides, and I get that the absolute value is now less than 0. Well, absolute values are always positive, so it's not possible for it to be a negative, and a negative is less than 0, so this is not possible, so we'd say no solution. So anytime you end up with less than 0, it's no solution. But, special case, if it's less than or equal to 0, now we have a different situation on our hands. Yes, it can't be less than 0, it can't be negative, but it can equal 0. And so when you have this scenario where you know it can't be less than 0, but it can equal 0, you just solve it like it's an equal sign. And so this was going to have one solution versus being on a number line. And so x would only equal 2, and Desmos really won't help you with this one. Hope this video helped.